Alright, so right on the verge of converting our wave data into a PCM stream. So the first thing we need to do, well, for one thing, just dawned on me that we're generating a sine wave here that's going to go from -1 to 1, so basically that's going to be full volume. We don't want our wave volume to be quite that loud, so we'll fix that when we do that here. So we're going to use a working value here, and that's going to equal our wave data I, and we're just going to cut the volume on that by 1/3. Times 0.3. I did that as D. Let's do that as a float. And we're also going to, when you start mixing things together, you're going to make sure that this is constrained to the range that we expect it to be when we do this conversion. So I'm going to use a tool that's part of the XNA framework here. We use the Math Helper class, and we use a function called clamp. So what we're going to do is say, okay, well, this data point needs to be constrained to let's see, minimum value -1 and 1. Actually, these are floats. So we reduced our volume by 1/3, and we should never be over. When you start mixing, you can get levels over. We'll cover that a little bit later. Now we need to break this down into whole numbers. And I've played with a couple different methods to do this. I've had varying success with different ones. One that works best is that I've seen so far that works best is just to use a 16-bit, not new short, just a standard short. And basically what we're going to do is multiply the range. Well, here, this will become clear. So let's do, let's see, so let's just call this our 16-bit sample. So we have a assigned 16-bit range here, and we're going to set that equal to our, actually we're going to do short, and we're going to use the, I can't remember what this operator is called, but let's say working sample less than equal to 0. So we're doing this is an if statement. It's going to return one value or the other here. So if we are equal to or less than 0, let's do greater than or less than 0 here first. Then it's going to be working sample times short max value, and if it's negative, we're going to do working sample working sample times short min value, which that's going to be a negative, so we need to just convert that back around to a positive for that to work, and separate that up. So this should constrain it to a value of plus or minus 1, and now we've converted that to a 16-bit whole number. And this is the part that always gets me into fits. I can't ever remember if PCMs is going to be little endian or big endian, but we'll figure that out when we get there. So what did we call our PCM data? We call it PCM. That's a good name for PCM data. PCM data. And we're going to use I times 2 because we're doing 2 pieces here. And we're going to take, I think it's the high sample that comes first. So we're going to take the byte version of 16-bit sample, shifted right 8 places. So basically what we've done is we've taken the upper 8 bits, shifted them down, and truncated the numbers above. So we have a byte here. Did I spell that wrong? PCM data 2 equals byte. It should be right. I don't know why that's whining. Oh, because I got it backwards here. PCM. There we go. And the other piece, PCM data, is going to be I times 2 plus 1, because we're doing 1 byte up from there. And that's going to be even simpler. It's just going to be the byte of the 16-bit sample. Alright, so we have a tool for creating the wave data and converting that into a stream. Now we need to look at playing that stream. And we're going to use XNA to do that. So we are going to use, let's see, Microsoft XNA framework audio. It's called Dynamic Sound Effects Instance. And let's just call this there. And sample rate, we've already set that. And we need to know how many channels, so we'll just do a mono one. Otherwise we have to do another set of variables in there for the left and right channel. We can play with that later. Alright. And why are you wanting? No, there's new sample rate, audio channel, mono. What are we whining about here? Sample rate, audio channels. Yep, so audio channels, mono. Huh. I don't know why that's whining at me right now. That's just weird. And I'm wasting a lot of time trying to figure this out. Oh, probably because this is the wrong... It doesn't expect that to be a float. That'd be my guess here. Yeah, it's an int. That's my problem here, so let's just recast this. There's an int for that. There we go. Problem solved. Alright. And we're going to need to do a couple of things to make this work. Let's go ahead and just start our first piece here. So, just right here, what we need to do is let's create our first sample and get it to play. So, we need to generate wave data, convert to PCM. No, overload. Wave data. I'm just having all sorts of fun today. Oh, that's because I used the wrong function. I used too closely named things here. There we go. So we've got those. And before we run eventually we're going to take this audio player. Let's see. So let's put that buffer there. So audio player. We're going to submit buffer and ACM data. And we're going to have to wait for the next video for the next part.